Hey guys, so last time we talked about discrete random variable, how to distinguish those, and also how to find the mean and standard deviation. So let's go ahead and move on to our next topic, which is going to be the binomial distribution. So binomial distributions are a specific type of discrete random variable distribution. So again, there's discrete possible outcomes, there's probabilities associated with each of those outcomes, but the specific type is that they refer to independent events. I remember independent is that one event happening has nothing to do with the probability, or does not affect the probability of the second one happening. And so these are specific types of discrete problems in the sense that there's only two possible outcomes. So you either get heads or tails if you flip a quarter, you win or lose if you're playing a game, you pass or fail if you're talking about a test, or you're right or wrong if you're talking about a question. So there's always two possible outcomes. And now these two events are referred to as successes, and failures. And now there are probabilities also associated with each of those. So we have probability of success is P and probability of failure is Q. Now, even though success kind of normally in our sense means something good, it actually doesn't always mean that it's good. So for example, it could be, what's the probability of you killing your baby, right? It's whatever you're interested in. Whatever the problem is asking you for, that's the one that you're going to focus on. So there's two outcomes. So one's always just going to be a success and one's always just going to be a failure. Success, again, is just whatever you're interested in. So now, let's talk about what the distribution looks like as this probability of success changes. So suppose you like flipping quarters, so you flip 4 just for fun, and you want to see how many heads you end up with, right? And so the probability of success for a normal quarter should be 50%, right? You should have a 50% chance of flipping a heads. So what we see in this distribution here is that what's the most likely outcome? It's 2 heads, right? And that kind of makes sense. If it's a 50-50 chance of getting heads or tails, you flip it 4 times, you should be getting 2 heads total, right? So 2 is the most probable, and as you move away, it gets less and less probable. And so that's where we have probability P is 0.50 and Q is 0.50 as well. This is for heads, this is for tails. And we see that this distribution here is symmetric. Right? And so 50-50 chance. So the midpoint is basically the most likely to happen, and then we move further. It's less and less likely. For example, if you flip 4 quarters, then we get 4 heads ahead every single time. And also, it's equally as unlikely for us to get no heads at all. Does that make sense? Cool. So now let's move on to, let's say, a fixed quarter, right? And so we mess with this quarter a little bit, so the probability of us getting heads is now half of that, of what it used to be. So now it's a 25% chance of us getting heads. So that means we have a 75% chance of getting tails, right? Because this is tails and this is heads. So this distribution here, we see that since the probability of flipping a head is less now, we're less likely to end up with more heads. Does that make sense? So we should be running into the situation where we get less heads than the probability of us getting more heads. So we see there, for example, the probability of us getting 1 head is more likely than all the other possibilities because it's a 25% chance. So if it's a 25% chance of us getting heads, if we're flipping it 4 times, we should only get 1 head. That should be the most probable or most likely outcome. And as we move from there, it kind of breaks down on both ends. And so what we see happening is that we have a distribution that's skewed in what direction? Skewed to the left or right, do you think? Skewed to the right. Good. And now let's move on to the other end. So in this end, we have the probability of us flipping a heads is 75%. So we mess with this quarter in the opposite way so that it flips most likely to get us heads. So now we see the opposite situation happening from the first graph, right? We have, it's very unlikely that we're going to flip 0 heads and very likely that we're going to flip 3 heads. Does that make sense? And that has to do, again, just with the probability of success being 75%, which means that our probability of getting a tail is 25%, right? So we're more likely to get more heads than we are to get less heads, right? And it's just because, again, those probabilities at P and Q. Cool. So let's move on to now getting the mean and standard deviation. So the mean and standard deviation, sigma, of the binomial distribution are simpler than those for other discrete random variables. So for the discrete random variable, we had this crazy formula for the mean, an even crazier one for the standard deviation. But now for the mean and standard deviation of a binomial, it's very simple actually. It just ends up being n times p, which n, let's go ahead and refer back to our variables list here. So n is the number of trials, so how many times do we flip this quarter? How many questions am I asking? How many people are in our situation? So it's the total number of trials, and x is the number of successes, right? So if we want 3 heads, that means our number of successes is 3. And then remember again, p is probability of success, and q is probability of failure. So n times p is what's our total number of trials times the probability associated with it. And then the standard deviation is the square root of number of trials we have times the probability of success times the probability of failure. So let's go ahead and apply this real quick to some problems. So suppose you flip 6 quarters. What is the expected number of heads and the standard deviation for this distribution? So let's just write our formula out. The mean is supposed to be NP, right? So n, how many trials are we running? We're flipping it 6 times, right? So we're flipping 6 quarters, and our probability of success should be what? Assuming that we didn't tamper with these quarters at all, it should be 50%, right? So our mean of our distribution ends up being 3. So if it's a 50% chance that we get heads, we're flipping 6 times, there should be only 3 heads. That should be the most probable or the most likely or expected outcome, right? Now let's do the standard deviation. It's the square root of NPQ. So our n again is 6. Our probability of success was 0.5. And our probability of failure is what? It's going to be 0.5 as well. And the reason for that is because if these are all the outcomes, right? We only have 2 outcomes. These 2 outcomes, the probabilities associated with them, P and Q, should equal 1. Does that make sense? Because again, we're talking about a sample space, right? So if our sample space only includes 2 outcomes, those 2 outcomes probability should add up to 1. So now 6 times 0.50 times 0.50, so standard deviation, we end up getting 1.22. That's about it. Pretty simple compared to what we just finished doing with the discrete random variables, right? So now let's move on to example 2. You have no idea what your 100 question exam is about, but you sat in class a few times. It starts in 5 minutes, and you know there's about a 60% chance that you get a right answer. And this is, again, just an assumption, right? It's totally made up. So provide a measure of spread for this average. I'm sorry, what is the average number of questions you'll most likely get correct, and provide a measure of spread for that average. So let's do this again. Our mean is n times p. N in this case is what? So how many trials are we running in this situation? It's going to be 100. We have 100 questions that we're testing, right? And what's the probability of us getting one of those questions right? Or success? It's 0.6, right? So the mean is 60. It pretty much makes sense, right? If you expect to get a 60%, a question is 60% likely for you to get it right, you should be getting 60% of the 100 questions correct, right? So that expected value is very easy to understand. And then let's move on to the standard deviation. Square root, again, n is what? We have 100 trials, because we're answering 100 questions. What's the probability of us getting a question correct? 60%. The probability of us getting a question wrong, aka failure, right? So Q, is 40%. So once we work out the math for that, we should be getting a standard deviation of 4.90. Cool. So that's basically binomial basics. What's a binomial distribution? How can we distinguish that from a discrete random variable distribution, right? And then also, how do we get the mean and standard deviation? So we see that's a lot easier. So if you're given a lot of these questions, great, because we won't have to do as much math as we will with the discrete random variables. So now that we've done a couple examples, let's move on to the practice set.